Can everybody hear me? Excellent. All right. Good evening. My name's Tony. I work on Reveal at Itty Bitty Apps, which got a lot of headline there at the start. Thank you very much. Tonight, I'd like to give you a demo of a set of really useful accessibility, debugging, and verification features that we've recently added to Reveal. I'm sure that some of you have already seen them, and hopefully more than a few of you have tried them out on your own apps. But for those of you who haven't heard of our plucky little macOS app, I'll first run through a quick high-level overview of what Reveal is. After that, I'm going to risk chaos and disaster by giving you a live demo of the new accessibility features, so pray to the demo gods if you believe in them. Sound good? Great, let's go. All right, Reveal's a product and really a passion project developed by Itty Bitty Apps for very close to 10 years now. It's a productivity tool for mobile developers in the Apple ecosystem, and it's used by thousands of developers from indies right through to developers working at bigger companies like Google and Uber. We built Reveal partly because we could see a need for it in the work we were doing with our clients, and our developers, designers, and QA people use it in their work. It often solves real-world problems for us and for clients really quickly. So what does it do? Primary use case for Reveal is when something's not quite right with your user interface. It might be that something's not showing up in the right place or the right size or even at all. It could be that the colors or the shape of your view hierarchy aren't quite right. Importing your app's view hierarchy into Reveal will help you to quickly identify underlying issues that can cause these problems and more. Reveal also lets you modify the properties of your layout elements at runtime. It allows you to quickly experiment without having to rebuild your app. This is fantastic for testing out finicky font and color combinations in place. In many ways, Reveal is quite similar to the element inspectors in modern web browsers, except that our DOM equivalent, the view hierarchy, is considered somewhat private. And as native developers, our build run cycle is significantly slower than that web developers have. But I'm not here to talk about the layout debugging features tonight. Until this year, Reveal's been tightly focused on improving the run code debug cycle for app layouts. As you probably know, apps developed using Apple's mobile UI framework, UIKit, have a direct link between the code that you write in Xcode and the view hierarchy that your app builds in memory when it's run. With the recent introduction of and the ongoing adoption of declarative UI frameworks like SwiftUI, we're looking at a future where the code that you write has little or no technical correlation with the view hierarchy that your app ends up building at runtime. And that's great, don't get me wrong. I'm excited to force feed SwiftUI into all of my projects, whether it's appropriate or not. I've experienced the soaring highs and the fury-inspiring lows of SwiftUI, but when it's finished, I think it's going to be really, really great. What it does mean, though, is that some point in the future, not just yet, Reveal's layout debugging tools may end up being less useful when most of our apps are built using frameworks like SwiftUI. And we'd really like to continue being useful. So we looked carefully at other pain points in the development workflow that we might be able to improve and found one that wasn't just painful, but it was also incredibly meaningful. And that's accessibility. So Reveal's new accessibility workspace gives our users the tools to inspect, experience, and verify that their apps are accessible to all of their users. I'm sure many of you are aware of the statistics around accessibility, but let's run through a couple of them anyway. So roughly 15% of the world's population experiences some form of disability. Here in Australia, we have a not-for-profit organisation that provides services to people who are blind or have low vision that's called Vision Australia. Now, according to Vision Australia, in Australia alone, there are currently 357,000 people who are blind or have low vision. This number's only going to get bigger. They're projecting that it's going to grow to 500,000 people by the year 2030. In addition to that, roughly 8.5% of all Australians have some form of colour vision deficiency, or colour blindness as it's more commonly known. In research published by Apple in May last year, 94% of the apps that they looked at had at least one screen that was not properly accessible. And for anybody who works in the industry, we know it doesn't take much to render a screen unusable for a subset of your users, and regressions to accessible UIs are frequent. So, we've spent the better part of the past year investigating, prototyping, building, and talking to experts in the field about improving the tooling around how we all build accessible interfaces for our apps. Our goal is to help developers create great accessible experiences by putting the accessible interfaces of their apps front and center, by making it easier to see what's going on. Our hope is that this will create a virtuous cycle, as it has for things like unit testing, where improved awareness and tooling will lead to better processes, and hopefully to better apps for everyone. So, let's set some context. What you're seeing on screen right now is Apple's Accessibility Inspector, an app that ships along Xcode. It's really the only developer tool that we currently have available to manually test accessibility in apps built for their platforms. It's an app that can really only be described as unloved. It does what it needs to, but it's slow in use and it requires you to manually focus on each accessibility element to see its details. To meaningfully test accessibility with this tool takes time. It's slow in part because the process of manual testing requires a familiarity with the accessible user interfaces of your devices, and it's arguably hard for exactly the same reason. So, let me show you how we at Itty Bitty Apps think this should work. Cross your fingers, guys. Let's hope this is going to work. All right, let's bump over. Okie dokie. Can we see a simulator on screen at that end? Excellent. All right. What I'd like to do during this demo is explore how much faster Reveal can be for debugging the accessible interfaces of your app. To do this, I'm going to use a simple demo app that James, one of our... No? We're missing stuff? All good, okay. So James put this together for us specifically for this purpose, and it's appropriately called Itty Bitty App. Right, so let's connect to it. It's got 3 screens in it, and we'll run through each of them. The first example is a fairly standard view of the weather for today, plus an overview of the weather for the coming week. The UI looks pretty great, doesn't it? It's reasonably well laid out. The colours are mostly bright and they present in a high enough level of contrast. The fonts are also pretty large and readable. First up, this screen's built entirely SwiftUI. So the work that we've been doing with the accessibility workspace fully supports apps and views built using SwiftUI, whether it's from the app level or just individual views within your screens. We also continue to support UIKit apps running on iOS, iPadOS, and tvOS. So the new accessibility workspace that we've built gives us 3 modes that we can use to inspect our app's accessible user interfaces. And they correlate pretty closely to Apple's own accessible user interface tooling. First one is VoiceOver, second one's voice control, and then there's also a set of industry standard color contrast checking tools. So let's dive in and have a look at the first of the accessibility workspace's 3 modes, which is VoiceOver Mode. For those of you who don't know, VoiceOver is a feature of all modern Apple devices that reads aloud the accessible user interface of what's currently on screen. It's a critical feature for blind and low vision users. Traditionally, building, verifying, and then testing the VoiceOver UI of an app involves walking through each screen an element at a time in Apple's Accessibility Inspector. Alternately, you can load your app on a physical device, turn on VoiceOver, and test the interface directly. In Reveal's VoiceOver mode, we present all of your app's VoiceOver UI in one go. You don't need to click through each element to find out how something will be read aloud or wade through VoiceOver on a physical device. It's all here on screen at once. The navigator on the left shows the accessible elements on this screen, numbered in the order that VoiceOver will read them. This allows you to see and resolve potentially confusing user interface due to the order in which elements are read. The label of each row in the navigator shows what will be read, and it's accurate to what's on device. Anyone who's tested Apple's Accessibility Inspector can tell you that there are subtle differences between what a physical device will read out to your users versus what ends up being presented by the simulator while you're developing and testing. Selecting any row in this navigator shows more detail for that element and allows you to identify potential issues with the accessibility properties of your elements, such as labels, traits, hints, and values. So let's have a quick look at one of these types of issues now. If we filter this view hierarchy, this accessibility hierarchy, and look for elements that have the image trait, we can see a pretty big oversight in this view. The weather descriptions in this view rely solely on the out-of-the-box localized descriptions that SF symbols provide by default. SwiftUI has been really clever here by providing this localized description, and for some elements, such as the breezy symbol, this works great. But the icon for when it's sunny reads to VoiceOver as brightness higher, comma, image. We should fix that before we ship this to users. The navigator can also highlight opportunities to group elements into more meaningful singular elements. Turn that off now. For instance, if we look at the entries for each day under the next week, we can see that it's just a jumble of short words and numbers. The first row is going to be read out as Friday, 28 degrees, 12 degrees, brightness higher, image. It's not great. There's not enough context in that for it to be useful, and to be honest, it borders on gibberish. But Reveal made it super simple to see that it's a problem by putting everything together on screen like this. Okay, moving on. Voice control is also a feature of most modern Apple devices, and it lets you navigate the accessible user interfaces of your app using spoken commands. It's often used in combination with VoiceOver, but they can be used independently of each other by users who have difficulty physically controlling their device. Reveal offers a mode that exposes this accessible user interface in a similar fashion to the VoiceOver mode that I just showed you. So let's switch to that now. Voice control mode is very quickly showing us that for this screen, there aren't any interactive elements beyond the tab bar items at the very bottom. And for this view, that's exactly what I expected. We'll come back to voice control mode in a minute with a more full-featured example. In addition to our VoiceOver and voice control modes, we offer a final mode that allows you to check the contrast of your app's visible user interface. At present, there are no real shared or formal guidelines around colour and colour contrast for native applications. What we do have, though, is the W3C's Colour Accessibility Guidelines, or as it's affectionately known, WCAG. Reveal supports WCAG version 2.1's AA and AAA checks, which are great for quickly identifying potential areas of your user interface where there's just not enough contrast between elements. In the next release of Reveal, we've also added beta support for the new Advanced Perceptual Contrast Algorithm, or APCA, both bronze and silver levels. When it's finished, this algorithm will form the basis of the next generation of the W3C's Colour Accessibility Guidelines. That's version 3 of WCAG. APCA takes into consideration a whole host of properties and situational conditions that WCAG 2.1 does not, including text size and weight, as well as human perception. Interestingly, humans don't perceive contrast linearly across hue and lightness, so APCA has been designed to take this into account. It's a big improvement, and I'm happy to say we'll be supporting it shortly. And we're committing to staying abreast of changes to APCA as it continues to develop. So let's have a quick look at the contrast of this screen before we move on to another example. In contrast mode, we can see that there is a slight issue with the nighttime temperature labels as they get closer to the bottom of the screen. This has been caused by the gradient background. The contrast on the inactive tab bar items is also far too low. They are still interactive, so they should be visible. We'd want to fix this before shipping. In addition to the modes that I've just demonstrated, Reveal also supports filtering your visible UI to let you experience how a user with colour vision deficiency or colour blindness would see your app. These filters are great, and at this stage they're pretty unique. iOS offers on-device filters to correct the effect of these conditions, but Reveal's filters let users who don't have a CVD actually experience a simulation of it for themselves. So if you're one of the 1 in 100,000 to have blue cone monochromacy, the colour of the active tab won't be very visible if we shift to the colours that are currently in this example. Let's just turn that on and have a look. So you can see down here, it's almost completely invisible on this screen. All right, let's move on to another example. This next one looks a bit like a popular code hosting platform, so I apologise for that. We'll bump over. Go to the next screen. Okay. This is a really text-heavy interface, again created using SwiftUI. If we filter this screen for elements with the header accessibilities trait, we can see that this screen has 2 headers, which is great. Information-dense apps can be really slow to navigate using VoiceOver and voice control, and including proper headers can dramatically improve the navigation for users who do use these interfaces. Let's clear that guy off. Here's another useful visual filter that we've included. It's called Screen Curtain. Now, what Screen Curtain lets you do is hide the visual user interface of your app, allowing you to very cleanly and clearly focus on the accessibility interfaces. Looking at both the navigator and the canvas with the Screen Curtain effect active, we can see there are a number of problems here. Again, grouping of elements is what we're looking at. Beyond the lifetime stats, let me just find this guy down here. Beyond the lifetime stats area, where each element has been automatically grouped by SwiftUI's list, this is something you get for free, most of the other major clusters here probably should be grouped but aren't. Now, we did see this in our earlier example, but it's almost impossible to follow what's going on in terms of the order of elements in this interface. what is the context of these numbers? We're looking at numbers and dates, and they just don't go together. It's not good at all. All right, let's move back to voice control mode. So in a more fully featured example, set to voice control mode, we can see that the navigator displays the interactive elements with their numbers and labels. Voice control allows you to speak either of these to activate an element's action. We can see that most of the labels on this screen are synthesized from the accessibility label of the element, so they're not particularly useful for describing an action that the element will perform. This is another issue that we'd want to address in this screen by setting or customizing the appropriate accessibility properties. All right, moving to another of our color vision deficiency filters, we can experience how a user with deuteranopia, a form of red-green color vision deficiency, would see our app. It's visually pretty clear straight away that there's a significant issue with the colors. You can see here with what we've used to represent the added and removed lines, that's just not going to fly. It doesn't hold any semantic meaning for people who have this form of color vision deficiency. So the algorithms that we've used to implement these filters are considered best in class. We consulted with Vision Australia during their development to make sure our implementation was really representative of these conditions. Now, it's important to note that all of our implementations in these filters pitch to the extreme end of these conditions. So this is as bad as it gets, but they're representative of those worst case scenarios so that you can see very quickly where there's an issue. All right. An interesting thing is if we switch to the color contrast checking mode, it will work with the active filter at the same time. So it's basically going to show us there's not sufficient contrast for people on these labels either. Okie doke. Turn these filters off, switch back to VoiceOver. Now, my final example is a pretty little onboarding screen that we pulled together. And it was completely created in UIKit. So in VoiceOver mode, we can quickly see that our quite visible button elements down the side here are missing, and that the frame of our Go to My Account button down the bottom here isn't quite what we'd expect. It's a little bit sus. So the three vertically stacked buttons are custom views that inherit from UI view, not from UI control. So they're not automatically exposed to the accessibility hierarchy like UI control subclasses are. Now, I can't be the only one who's been frustrated enough with the API of UI button that just ended up rolling my own subclass. Reveal makes this kind of oversight really easy to catch. So our Go to My Account button at the bottom is also custom, but it has a label subview that is a UI label, which does get automatically exported to the accessibility hierarchy and will be read as a static text element. It's pretty clear that this isn't what we intended here. The accessibility frame doesn't even remotely match our button's visual frame. So let's have a look at how this looks in voice control mode. Right, voice control doesn't offer much here. The elements we're expecting to be interactive are custom and therefore inaccessible. See how fast we're able to check all this? Our team at Itty Bitty Apps have been using this version of Reveal for a little while now, and it's saving us time every time we need to work on the accessible interfaces of the apps we're involved with. Now, if we switch back to one of the color contrast checking modes, there's a little bit of a surprise on this screen. So let's just bump over. So that fancy background graphic, he's lowering the text contrast where it intersects with the labels. It's not by much, and it only just fails WCAG 2.1's AA accessibility checks. But because this is a UIKit hierarchy, we can actually leverage one of Reveal's other superpowers, which is modifying the view hierarchy at runtime, and test a fix for this in place. So let's switch back to the layout workspace. We'll need to refresh. And what we can do is grab onto that image and have a look. I'm not 100% sure what's going to work here, but I think if we reduce the opacity of this view a little, say to 10% rather than 30%, it might end up fixing the issue for us. So let's do that. All right, you can see there it's reflected that change. Let's switch back to the accessibility workspace and see whether that fixed the issue. Here we go, bravo. That fixed it. So we can then pass that on to our design team, or we can have a chat to them about it and let them know that it fixed it. I mean, to be honest, I think our design team could very easily use Reveal to uncover these issues themselves if they were keen to do that. Okie dokie. So that's the end of my demo. I'm going to switch quickly back to my slides. Give it a sec to catch up. Okie dokie. That was pretty cool, eh? I hope you can see just how much faster Reveal is for checking your accessible user interfaces than the existing tooling we've had to date. Alongside all of the features I've just shown you, we've made sure that when you save a snapshot from Reveal, it's going to save out the accessibility data right there alongside the layout data, like it's always done. This lets you share a full fidelity capture of a problem as you're seeing it on a specific device, OS, and application version. Really, really useful. We've also included the ability to copy or save nicely formatted images of what you can see in the new accessibility workspace, and you can see a few samples of these on screen right now. These images are great for sharing with your team when you need to quickly and clearly demonstrate an issue. We attach them to GitHub issues, discussions in Notion, and often copy and paste them directly into our Slack channels. So that was everything I had to show you tonight. I'm really happy to have been able to demo this to you all, and I want to thank you for your time. I hope that you enjoyed what I've shown you, and I'd really love for you to go and try Reveal's new accessibility workspace on your own apps, and please let me know if you do. So that's it. Did anybody have any questions?
Well, all right, lots of questions. Hang on a sec. Take it in turns, guys.
Yeah, I'm just curious to know if it also works with a web view.
No, it doesn't. It doesn't work with web views, sadly. So web views in a lot of, or most of our applications are hosted out of process, and we can't get to those. We come in through your actual application, so no.
Thanks, Tony.
Yeah. Hey, Tony, it's Chendo. I love that view. That would be amazing. My only question is, would we be able to use it on Mac apps? Because you are right, the accessibility inspector that Apple ships is horrendously bad, and it needs to be burnt at the stake. So, yeah.
Yeah, sorry, Chendo. It doesn't work with AppKit apps at this stage, or Mac apps. We've had limited success getting it to work with Mac Catalyst, but I think in the current release of Reveal, it's not a going concern at this point. So we'd like to get there, but not at this stage.
Cool.
Were there any other questions?
G'day, Tony, it's Pete.
Hey, Pete.
Less of a question, more of a comment about how powerful this is. So previously at ASOS, we had to do these demos where we would be using the screen reader on device and go, look how terrible this is. You need to care about this. Whereas like when I use this at REA, take one screenshot of Reveal and lots of using previews annotations for arrows and go, terrible, 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 terrible. It's like so much easier to convey that conversation internally that like the screen accessibility, like the voiceover is just much easier to capture in this as opposed to trying to record a demo of the actual screen reader. So yeah, no questions, as a comment. Keep up the good work.
Really great. Thank you.
Hi Tony, just a question on behalf of an in-person attendee, Amy, in the hashtag meetup channel. She's loving that the Reveal's accessibility tools just work with SwiftUI. It's a really nice feature, and she would like to know, will there be a version of Reveal released that can do accessibility review and testing for macOS apps? But I feel like we already answered that, so I didn't read the question before I asked you. Sorry, thanks mate.
That's okay. Yeah, none at this stage.
Hey, I have a question then. As has been pointed out several times, it's great if we can... it's a great way to go back to your developers and your designers and say, hey, this stuff's non-compliant. Is there a way we can run this in CI to have it automatically spit that sort of report out and fail the build if it doesn't have properly accessible views?
With the current release, no. But I think I'm allowed to say that that's something that we will be looking at shortly. So, yes.
That's great news. One volunteer for beta testing. Were there any other questions for Tony? Anything else? No? Cool. Thank you very much.
Thank you very much, everybody. Have a lovely night.